Hey guys, welcome back once again. This is Nagaraj SK, lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belagavi. Here in this session, we'll move to the lecture number 41 and 42, and with this lecture numbers, I am going to begin with the unit 5, that is decrease and conquer. So here we'll learn what is decrease and conquer and how it works, right? So what are the variations of this decrease and conquer? So at the very first introduction, the decrease and conquer technique is based on exploiting the relationship between a solution to a given instance of a problem and a solution to its smaller instances. Then once such a relationship is established, it can be exploited either top down or bottom up. The former leads naturally to a recursive implementation, although, as one can see from several examples in this chapter, an ultimate implementation may well be non recursive. The bottom up variation is usually implemented iteratively, starting with a solution to the smallest instance of the problem. It is called sometimes the incremental approach. So, here in the decrease and conquer, there are three major variations of this decrease and conquer. So one is, first is the decrease by constant factor and variable size decrease. So we'll learn those, what is decrease by constant, what is decrease by constant factor, and what is variable size decreases. So let me move to the next slide. That is, as I told you, there are three major variations of decrease and conquer. That is decrease by constant, decrease by constant factor, variable size decrease. So decrease by constant. So in the decrease by constant variation, the size of an instance is reduced by the same constant on each iteration of the algorithm. Typically, this constant is equal to 1, although other constant size reductions do happen occasionally. Here, uh, I'm going to brief you about this decrease by constant with the help of this diagram, that is problem of size n. We have a problem of size n and we are decreasing that problem of size n by 1, that is subproblem of size n minus 1. Solution to the subproblem, then solution to the original problem. This is the way we are decreasing by a constant value, that is decrease by 1 and decrease and conquer technique. So here I'm going to consider one example, that is the exponentiation problem of computing a raised to n, where a is not equal to 0 and n is a non-negative integer. N is a non-negative integer. The relationship between a solution to an instance of size n and instance of size n minus 1 is obtained by the obvious formula, that is a raised to n equal to a raised to n minus 1 into a. Then so the function f of n is equal to a raised to n can be computed either top down by using its recursive definition, or bottom up by multiplying 1 by a n times. Yes, it is the same as the brute force algorithm, but we have come to it by a different thought process. So more interesting examples of decrease by 1 algorithm uh, we can learn and we can study in a deep manner in later stages. So this is about decrease by a constant. Then what is decrease by a constant factor? The decrease by constant factor technique suggests reducing a problem instance by the same constant factor on each iteration of the algorithm. In most applications, this constant factor is equal to 2. is equal to 2. That is, uh, for example, the decrease by what is that? Just a minute. In most applications, this constant factor is equal to 2. That is the decrease by half idea. Then, for example, let us revisit the exponentiation problem. If the instance of size n is to compute a raised to n, the instance of half its size is to compute a raised to n by 2, with the obvious relationship between the 2 is a raised to n equal to a raised to n by 2 whole square. But since we consider here instances with integer exponents only, the former does not work for odd n. If n is odd, we have to compute a raised to n minus 1 by using the rule for even valued exponents and then multiply the result by a. So to summarize, we have the following formula here, that is this one, this formula we have here. So a raised to n equal to a raised to n by 2 whole square if n is even and positive. Then if a raised to n minus 1 divided by 2 whole square into a if n is odd, and a raised to n equal to 1 if n is equal to 0. This is about decrease by a constant factor. Then what is variable size decrease, right? The size reduction pattern varies from one iteration of an algorithm to another. Euclid's algorithm for computing the greatest common divisor provides a good example of such a situation. This algorithm is based on formula GCD of m comma n equal to GCD of n comma m mod n. Other examples like computing a median and the selection problem and interpolation search. So let us summarize what we discussed so far. We discussed what is decrease and conquer, different variations of decrease and conquer, and examples for them. So if you are having any doubts in this, please do ask your queries. Definitely I'll be helping out for your queries. So thanks for watching.